Well, hi there. We're trying something new. We're uploading this week's lunch gathering to YouTube. We hope that you'll enjoy it this way. If you would like to subscribe, there's a little red subscribe button down below and a little bell thing. And if you click on the bell thing, it will alert you to when new videos will be posted to the BDR.net channel. Let's see how it works. Thanks for listening. We're really happy, as always, to have Mr. Welton with us. Jeff Welton, Nautel extraordinaire. Tech support, what, 17 years was it, Jeff?
16 and a half, yeah.
Okay.
We'll round up.
And he's been on the road now doing as much tech support as sales on some days. And so it's a real pleasure to have Jeff back with us today. And we want to talk primarily about things that cause transmitter fires, things that cause building fires.
So the big thing that, and this is my first slide for anything to do with fire, is my big fire prevention tool. And if you don't have an infrared camera, you need an infrared camera, whether it's one of these cool little, let's see, I think I just happened to have it sitting right beside me, probably from last time we talked about this. But the little FLIR one, I mean, tiny little thing, plugs into the USB port on the bottom of your phone, turns the phone camera infrared, or whether you've got a Fluke laser guided point and shoot. You need to know if you've got any hot spots, ideally before they catch fire. I didn't notice, is Chuck Lakatos with us today, Barry?
No, I have not seen him yet.
Okay. Chuck had a big fire when he was up in Barrow at KNOM. And what it got tracked back to by the fire marshals, because of course I hear about a fire in a transmitter site, and if it's not my transmitter, I breathe a sigh of relief, and if it is my transmitter, I worry. But what it came back to in that particular case was an electrical outlet, regular 120 volt electrical outlet with a loose connection on it. Got hot, burned up, bad stuff happens. I replaced my wall oven, 4 or 5 years ago, and when I took it out, the guy that had wired it originally apparently didn't have quite enough Romex, the armored cable, to get all the way to the box, so he left like 6 inches of bare wire, just individual conductors. Not recommended. You couldn't tell white from black because they were all nice and crispy black. And when I moved it, all the insulation fell off. So, I was one kid bouncing off that wall away from a good fire here, too. So definitely a thermal imaging camera is huge. You can go through, you can scan your breaker panels, you can look at your coax. Depending, I mean, they've got now, and I've seen several consultants doing it, but doing drone inspections of towers. And you can get them to do infrared scans of your antenna, look for hot spots, so you don't have the radome go dripping down the tower, as Clay was talking about last week. So that's the kind of cool thing. The one thing that always worries me is when I look into the bottom of a transmitter and see something like this, and then you look up and you see something like that. Okay, and that's the sort of thing that an infrared scan or a regular hardware check, because we all go into our boxes and check all the nuts and bolts on a regular basis, right? That sounded almost like sarcasm. Yeah, preventative maintenance. No, no, no. We just go out and after it caught fire, and then we'll put the fire out and start all over. I had one guy tell me once, a station owner, and a perfectly straight face, he said, well, he goes, if the site burns down every 3 years, it still cost me less than paying an engineer. Wrap your head around that concept for a little bit. Now, fortunately, his call sign now starts with D, so that's less a concern. But yeah, it's one of those things that we really need to focus on selling the need for the maintenance. And I mean, this is a prime example because if you've got anything, and I beat this drum, I hate compression connections with a passion. But anywhere where you've got a stranded wire going into a compression connection, unless you've displaced all the air, then it is going to eventually work a little loose. And when it works a little loose, it's going to get a little hot. It's going to oxidize, which adds resistance, which makes it hotter. And, it just cascades from there. I know I see, so I've got the abridged view and I'm looking at Mark and Jerry and Kelsey and Barry and Elaine. And it's like, okay, well, I already know there's at least one good fire story just on that page. Kelsey's nodding his head already. So we're going to be opening up the mic in a couple of seconds too. Again, compression connections, bane of my existence. Don't like them at all. But if you've got a AC stranded wire coming into a terminal block, that's how it's going to be tied down almost always. So you do need to allow the time to go in on a regular basis with in this case, Allen key, and check it out. Now, of course, if you've got our gear or a lot of the other stuff, you'll need a metric Allen key. And I don't know about everybody else. We provide it with the transmitter, but they're not that hard to get. Home Depot carries metric stuff too. The other thing for fires is arc flash. I am not doing an arc flash presentation. Number one, I'm not qualified to do an arc flash presentation. Suffice it to say, if you take the volts at your service entrance and the amps at your service entrance and multiply them and get a higher number than 125,000, by OSHA requirements and NEC, you should have arc flash training and specific PPE on site. Okay, so 125 kVA is the nominal threshold for arc flash. I think it's 150. I like to be a little cautious. But so take your volts of if you got a 480 volt entrance in the US, rated at 500 amps, you're well into arc flash territory, and that requires specific training and protective equipment that you really do need to be aware of. Okay, and that's something, again, a lot of us don't think about it, but if you're running a 50 kilowatt AM or even a 40 or 60 kilowatt FM, you're in that territory on a broadcast site. Okay, if you've got a facility with main standby transmitters, the entrance is probably sized big enough. So those are the kind of things that you really want to pay for, or pay attention to, rather. It's just, sorry, got sidetracked because I saw the subtitles went Maine as the state, not Maine as primary. I may have to learn to speak differently to accommodate the subtitles too. Has anybody got a site that looks anything like this? Kelsey says no.
Oh, of course not.
Has anybody got a site that they'd want to admit to? So now, in their defense, this particular site, you'll see you've got, for the 240, you've got one outlet per wire coming in. So it's not like they've got, the string of extension cords or anything like that. But there are there's a lot of current being drawn in one small location. And, with the wiring the way it is, it's a risk. If nothing else, there are a grand total, and there's another picture a little later, but I posted the other picture with a caption in a different presentation, so we'll hit that in a bit. But yeah, I tell folks, if the cleaner you can keep it, number one, it's easier if you do a thermal scan to figure out what wire's hot, if you know where that wire is. But when you've got a jumble, like in the back of that transmitter, we got AC, we got Cat5, we've got coax, we've got audio, there's a little bit of everything. So it makes it harder. Now, we got some Westerners here, West Coast folks. Y'all remember when Crawford had the fire on Catalina Island? I think it was Catalina. It was KBRT, I want to say.
Yes.
Tower crew, their torch got carried away and set the grass on fire. And I mean, they had a well-trimmed site there. Mike Patton tells a story about parking his Jeep in a swamp, but had enough dry grass there to start a fire and burn his Jeep down. So keeping the growth trimmed, keeping the weeds down and the bushes down and the kudzu if you're in the eastern part of the world. But keeping that stuff trimmed will really cut down on the fire maybe not the risk of it. I mean, equipment can still catch fire, but you can definitely minimize the amount of damage. So that's one of the other things I like to beat the drum on. And so this is the other one. So can anybody tell me how many power bars are in this picture?
Too many?
Four. Four that I know of. I'll rephrase that.
How can
Okay.
you count them?
At least he's got a toroid.
I can count them because the pair of feet to the left of those feet were mine. I was actually down there looking. But yeah, yeah, there you go. There's a toroid on one of the feet, so that's good. And yeah, they don't have a lot of lightning damage, but they've got a lot of additional inductance with the cabling too. So yeah, from a lightning perspective for lightning protection, that's pretty cool. From fire prevention, it's a little less optimal. So definitely, again, this comes back to keeping things clean and a little more orderly. You know, and this one, I'm not 100% sure exactly why I'd be pulling new wire into a cabinet like this, but stuff happens, you know. What do you get told? Make it work. But you got no budget and you get no new gear, so make it work with what you got. And that's when you get creative with your fuses. Folks, don't do this at home. I swiped this one off the internet. Somebody posted it. It was either on the transmitter site page or the broadcasting club. I can't remember, but it was too good not to share. I think Mark's lost it right there. I can see him in the camera. For what it's worth, we in the surge protectors we used to make, they're fused for 30 amps per leg. And they're the paper cartridge, those I call them oven fuses, but those paper cartridges with the metal cap on each end, they're nominally, well, I can tell you they're exactly the diameter of a 5/16 bolt. And the reason I know this is because we got one back that had literally exploded after somebody replaced all three of the fuses with 5/16 inch bolts. Don't do that. If somebody puts fuses in something that's there for a reason, maybe go up half a size. If it's, you know, if you got a 10 amp and it keeps blowing and the manufacturer says it shouldn't do that, try a 15. Well, okay, try a 15, but yeah, not bolts. Just don't. And one other thing, and this is I had a guy call me and he goes, we need to go take a look at my 50 kilowatt transmitter. And I said, all right, we go take a look at your 50 kilowatt transmitter. What's the matter with it? Well, it's off the air. Well, that is a problem. Okay, well, I'm in town. Sure, let's go take a look. We walk into the site and I said, I'm not turning the breaker on. Transmitters don't work best in puddles. Okay, so that's one of those little things that I had a guy, no word of lie, I had a guy call me one day during had a river overflow its banks, and he said, how deep can the water be in the transmitter room before I have to throw the breakers? And I said, can you get to the breakers without getting your feet wet? And he said, no. And I said, don't worry about it. It'll take care of itself soon enough. Yeah, you know, I mean, in a flood situation, there's not a lot you can do. You do what you can for, you know, putting dikes and moats and sandbags and mitigation, but at some point that is going to happen. The one thing I will recommend, if you know you're going to flood, if you can get another box into a standby antenna at a different site in higher ground, get it on the air before the flood gets into the building, and then go and shut all the breakers off in the building. Because electronics that don't have current flowing through them you've got a much better chance of cleaning them up, running them through a car wash, and getting it to run again. But if they've got current flowing through them, electrolysis will happen, and it'll never run again. Not right. So that was the sum total of the slides that I threw up there. If any, Barry, do you got any? I'm sure you've got some good fire slides too.
Actually, I have a couple that I could bring up, and I'm sure that some of the folks here have some others. What I want to do is before we just go wide open, I'd like to bring up a side topic that you often speak about. That's part of this, and we talk about the vegetation. We talk about the breakers and the fuses and things. Grounding. This is something you often hit in the discussions we've had together, and I've seen.
Oh, I never talk about grounding or ferrites or any of that. Never.
And I'd like you to talk for just a couple of minutes, if you would, about how grounding can lead to fires specifically.
So, a couple of different ways. And we had a similar discussion for the San Francisco SBE meeting last night. Yesterday, I guess it was their lunch. It was evening for me. But one of the things, if you don't have grounding, proper grounding, I'll quantify that because there's grounding and then there's good grounding, then you run the risk of feeding a lot of current through something that's not designed to have a lot of current running through it. And that's pretty much exactly how fires happen. So good single point grounding with a properly installed surge protector can go a long way. And again, it's lightning. You know, we're playing a voltage divider game. We're not going to stop the current from going where the current wants to go. All we can do is make this path more attractive than that path, so to speak. So, you know, we minimize the amount of current that goes in through our gear and try to direct it through surge protectors and outside of the building. And that's really the goal. But yeah, that's probably the biggest cause. I mean, obviously, if you get current flowing through anything, you're going to generate heat. So I've ran into one situation where the ground wire for a 50 kilowatt AM was a piece of, I think it was 8 gauge cable. 6 gauge, what do they use for ground radios? Soft ground copper, it's like 6 gauge, 8 gauge?
10.
10, there you go. That's what it was anyway. It was a piece of ground radial, was the ground wire. And they got a strike big enough to vaporize that ground wire and set the wall on fire where it was tacked to the wall. So, you know, again, good grounding or grounding. The choice is yours, but one of them is a whole lot safer.
While we have him here with us, I'm going to invite Tom Labarge to speak for a little bit here. Not that we want to get into to wide ranging other than preventing fires today, but Tom has spoken. It's on the website here about being at the end of a circuit, why it's important to have good power regulation and grounding. And Tom, what I'd like you to kind of address, if you could, is the myth of having ground of 0 ohms.
Is my audio coming through? I wasn't sure on that. I made a couple comments. Can you hear me?
Yep, you're good.
Okay, good. Thanks for that. So often engineers and other people who are checking on the performance of grounding at transmitter sites don't know what they're measuring. And they will put a clamp-on meter, a megger for those that are more familiar with that term. They'll put a megger meter on a grounding lead, not knowing where that grounding lead goes. And too often it's actually connected to a subterranean ring. Well, what they end up measuring is the continuity of the grounding system, not the resistance to ground. We've seen this all over the country. And the engineers will gladly announce, you have 0.8 ohms to ground on your grounding system. Well, no, you don't. One particular site has now blown up 3 times, we've been told. Their actual resistance to ground was 875 ohms, but they reported 0.4 to 0.6. They were doing nothing more than measuring the continuity of the grounding rings. It's unfortunate. Jeff, you're exactly right. There's grounding and there's good grounding. Yep. And in the case of the way we approach things, and I'm not going to advertise here at all, but you want to keep it outside your building. You don't want it even to think about getting inside the building. Once it's inside the building, all bets are off. So review your grounding situation as often as you can and make sure that it is resilient and can stand the high frequencies that do most of the damage. Most surge protectors can't even catch up with the high frequencies when they come in on a lightning strike.
Those are good points. Thank you, Tom. We've invited Tom back. He's going to talk more about grounding in the future. We're going to see some examples and really keep this discussion going, because it's so important that you may be putting power out in one direction and what's coming back you don't even want to think about. And Jeff, I know that as you go around and you see these different installations where they've had problems, just seeing that box sitting in the water, that's enough to scare you, and as it did. And yet those things are so common. I mean, we could talk about interlocks being jammed open. We could talk about the different things where there was a transmitter. I've got a picture of it on the website, where power was applied from two different directions. You thought it was turned off, and yet coming back in through the exciter or through the IPA or something, there it was, 220, and it was enough to shock the guy out the back door. And so you can't ever get enough talking about turn the breakers off, use the grounding stick. All those things about grounding are so important, but we're talking about burning down the house today. So let's go back to that a little bit.
Well, I'm going to shift or go back because Tom made a really good point with the emphasizing on the grounding and good grounding. And the one thing I run into more than anything, and this is why I wanted to sort of jump back to it, because it is fire related, is a lot of times you get a new piece of gear, get a new transmitter, or put in a new coax switch, whatever, and you'll run a ground for it, but instead of looking at that in relation to the existing ground system, it gets laid on over top as almost its own separate ground. And I've run into sites where over the years they've evolved so there were almost literally 4 ground systems stacked on top of the other, and nobody had any idea what was grounded where. And sometimes the solution is to rip it all out and start again.
Jeff, you are exactly right. And we see that in numerous locations. The worst place we found it, believe it or not, is in hospitals. Now, that's not a broadcast issue, but in hospitals. Hospitals grow very quickly if they're in the right markets, and they don't pay attention to their grounding. They blow stuff up. Radio stations, TV stations do the same thing. And you end up without equipotential throughout your grounding system as well. And that creates voltages all over the place that you don't want to see.
Yep. So Barry, I'll let you go back to it now and get it back on track. But yeah, that was one of the things that drives me nuts when I walk in and see about eight different ground leads to one piece of gear or something like that.
Oh yeah. You have power strips plugged into power strips, or number 10 copper that doesn't really go anywhere. And we've shown some of the pictures of things that you run into that just make you sit there and wonder how it is that that engineers that are competent will sit and let something like this exist. When you're using elbow glue in a little screw, that doesn't give you much of a ground.
Or the ones that they fold over and then hammer down flat.
That's for sure.
Because all that high frequency current just loves to bend around all those curves.
Yeah, inductance isn't a thing, really. If you imagine it.
Well, if you wrap it around itself enough and add some oxidation, then you can make a pretty good inductor right there. But yeah, again, if you're dealing with any frequency above DC, that's something that you need to pay attention to. And well, we've had me beat that drum so many times. You braze or Silphos or Cadweld. I love Cadweld. Has anybody ever hear me say I love Cadweld? Blowing stuff up on purpose. I mean, we're setting fire on purpose. How cool is that? There's a real Tim Taylor moment there. But yeah, it's that's the sort of thing that the ground system can literally contribute to the fire over and above the whether it's a good ground system or a bad one.
Anyone that would like to share their experience Anecdotally, if you got a picture, even better. But anyone want to share something that has
I've
happened?
saved thousands of dollars, many kilobucks by IR scanning. There are um, some corporations that actually pay to have somebody with a FLIR meter come and fly out and scan your panels, but those only happen, say, annually, and some companies won't even do that. I've bought the cheap infrared thermometers that just have the laser and a single data point. I've also bought the ones that it's not FLIR made. It's a perfect prime on Amazon, has a 320 by 240 infrared resolution. You can really see where the problem is with things like this, and it just fits in your backpack, self-contained. Fantastic little things, and you can justify them very easily by showing the pictures of, one, the hot spots, or two, where something was way too hot. So totally on board with those, and they've saved kilobucks.
Story about a competing TV station that I was at in Texas. They had brand new RCA transmitter, and it caught fire because of the wiring harness. But conveniently, the main disconnect for the station was behind the transmitter, so there was no way they could get back and kill the power. So when they replaced the transmitter, and I've done this in other places where you can't easily get to the breaker panel, is get one of those big red buttons that has going to a remote disconnect breaker, remote trip breaker. That one, the main breaker panel was on the floor below, so right inside the door I had that. So if there is a fire or starting of a fire electrically, you can just immediately kill the power to the station. And I've had that use that at one, or it was a piece of metal shaving behind an outlet strip, a barrier strip that they had 110 and it just arced through the front panel. So, hit that button quick, and saved. Was able to rebuild the transmitter that night.
You speak about electrical panels getting hot. It was purely by accident one day in our station that I was at, in the power, what we call the power distribution room. There were a number of circuits that were sent out of there with good size disconnects on them, and just happened to brush by one of those panels, and it was extremely hot on the cover. So we, of course, took the cover off, and we found what Jeff had shown in the one picture, where it had been arcing for quite some time, actually. So that's like a serious thing. I know once a year I shut everything down out at our main transmitter site anyway, and I hit everything with the wrench to make sure all those lugs are good and tight, so that that shouldn't happen. But we nearly had a fire from that. It was that was kind of an eye-opening moment. And the more I hear about these FLIR cameras, the more I'm very much thinking I'm going to start carrying one.
Jeff, Eric wants to know, how reasonable are their temperature readings?
Yep. I did send that to everyone. It really does depend on the surface that you're measuring. I have literally picked up my own reflection in the thermal image of a transmitter I was standing in front of. So you definitely do want to have a non-reflective surface to get an accurate reading. And I've been happy with mine. It's been very close to other thermal guns. But again, what I do is I'll tend to put black hockey tape on the points I want to measure. Black cloth tape, so it's non-reflective. I'm going to say, I guess the southern folks may not know what hockey tape is, but yeah, it definitely does help a lot. And like any other tool, it's as accurate as Well, like we were talking about with the grounding earlier, if you measure the ground system to itself, you're going to get a really low reading. So it's the accuracy is all in how you use it.
Kelsey, you're talking about an EDC camera that you've got?
EDC stands for everyday carry.
Well, there you go. Tell us about it.
Yeah, so it's the one that I mentioned. It actually does have the two cameras, visual and infrared. It's higher resolution than what you get with the FLIR product at the same or less price point. Battery powered, recharges over USB, internal storage, so you can just take pictures of it, and you can also change the response curve of it. That's not the right term, but you can calibrate it so that you're reading off of surfaces or off of skin. If you say like this past year, there's been a lot of interest in what's your skin temperature. You can calibrate it so that it will accurately reflect skin temperature. So very useful. It is a little more pricey than the ones that you plug into your cell phone, but it's far better on features. Again, I've also paid for it many times over in not burning things down. And also, to bridge off a little bit, it's not always electrical panels that get hot. I've had a AM station, this was up in Springerville, Arizona, had a very interesting grounding situation, and some of the cabling, the audio cables and the interconnects were getting hot. It was grounding. Infrared thermometer found, oh, well, this one's hot, this one's hot, this one's hot. You could also on some of them just touch them, and a 25 pin flat cable. Oh, there's the ground conductor. Move your finger. Yep, there's another ground conductor. So you can find some problems just by scanning pretty much anywhere before they burn down.
Jeff, I think, was it yesterday that you showed a picture, again, in a breaker box where everything was loose? Maybe that wasn't you. Maybe that was another one. You get Zoom meetings at your head here to a certain time. But the idea being that something you think would be not moving around, not having vibrations, but it still can get loose because of the heat and cooling cycle over a period of time.
It's not even that. I mean, copper itself is malleable, so if you put pressure on it with a bolt-down connection, it will eventually reform to displace any air in that space and become loose just by virtue of physics. So, it really doesn't even require heater, cooling, or vibration. I had a guy put a ground system in outside a mountaintop site in Arkansas. And about 3 months after he put it in, he was still having some failures, but they'd gone away for a little while and started to come back. And he was kind of discouraged, and I was in the area, and I like northern Arkansas, so I swung up and took a look. And he's showing me around this brand new ground system, and I get to where the main feed comes out of the building. He's got a 2-gauge cable, not my first choice, but it's what he's got. And I reach down and grab it, and it's got one of those pressure clamps onto the ground rod, and I stood up holding the end of the cable in my hand. And he was flabbergasted. He goes, I just bolted that down like 3 months ago. And it's like, yeah, well, it's loose now. So that actually, you see when you look at my grounding presentation, you've got the picture of the station owner brazing the ground. That's the guy right there. It was a learning experience for him, because anything where you've got a piece of copper and a screw down connection, unless you've got all the air displaced, which isn't going to happen, it's going to get loose over time. That's like, I run through my circuit breaker at the house. The whole panel gets run through every year. So now it's 15, 20 years old. It's probably as loose as it's ever going to get, I hope. But it is something that I do a regular check on.
Worth talking about. Let me ask this question in these terms then. Would you say, in your experience in seeing these things, that a change in the output load of a transmitter is a major issue in fires?
No. No, typically no. I'll quantify that. For AM, definitely not. Um, Depending on the transmitter, I guess I'm dating myself on the
Yeah,
solid
solid
state
state is going
side.
to cut back, isn't it? Whereas the old tube guys are just going to keep churning out
Yeah.
the
Now,
pellet.
where I've seen it, and I know that I see Bert and I see Clay and I see a bunch of folks that they can prove me wrong 15 different ways, but where I've seen it happen quite a bit of times in the past has been more with airflow interlocks being disabled and then the squirrel cage goes down. And it doesn't take long for the final cavity to reach pretty much supernova temperatures when you got no when you got no air flowing through it all.
That would make sense. You got to get that, keep that airflow going. That's probably one of the areas, Clay and we looked at this some years ago with the Continentals, the Collins Continentals, measuring the airflow through the filter, the manometer that you installed, Clay. That was an important thing. But the idea of the differential temperatures that need to set off alarms.
Yep. It's a really good point if you, and it doesn't take much. I mean, you can get 15 different kinds of temperature measuring equipment for not a whole lot of money. But if you're looking at intake and exhaust, I mean, the tube guys, y'all know how a lot of times some of the older tube rigs, you tuned them based on the differential intake to exhaust. You know, you looked at the exhaust stack temperature and that told you whether you were tuned or not. Well, on the solid state rigs, the manufacturer should be able to tell you the nominal temperature rise. Like I can tell you for our FM rigs, 10 degrees Celsius is about what you should see if your airflow's right. So, you know, if it's 18 degrees from intake to exhaust, you're probably all right. If something goes a little sideways and it gets a whole lot more, then even if your airflow interlock or your high temp interlocks are bypassed because somebody 3 engineers ago needed to bypass them and forgot to unbypass them, then it's belt and braces. It's a good warning system.
So, what are the first parts that will destruct under high temperature?
That's depends on what we're talking about. If we're talking about a tube transmitter, probably that's a good question. I would guess power supplies that go before anything. I mean, electrolytics tend to be really sensitive to high temperature. Solid state rig, you're going to see switching power supplies shut off before anything else, almost always. You know, now I can only, of course, talk to the air cooled. With the liquid cooled ones like Dawn's. If they had a pump failure and somebody had gone through and bypassed the fluid interlocks, which would be a really dumb thing to do, same as bypassing airflow interlocks. But I'm sure that similar systems or similar procedures would happen. You know, things are going to start shutting down as they get too hot. So, yeah, I'm not sure what would fail first, but it would be spectacular. In both cases, I should quantify. I'm not dumping on Don there because his is going to run cooler with the air or with the fluid flowing. It's going to be good.
Jeff, can you hear me?
Yeah,
Yeah, this is Bob.
I know.
Yeah, one of the things that I used to do when I was selling is back in those days, it was mostly contact with the engineers. And I'd always offer to come in and help install a transmitter. And one of the things that I always used to try to get across was to go in the transmitters before you hook them up and go and tighten every loose or every nut and bolt that you can find.
Yep.
And I'll tell you, it was surprising how many loose ones we found over the years. It was quite interesting.
You are putting that box on a vibrating vehicle for several hundred or thousand miles, and it doesn't matter how well we torqued everything. And of course, everything different screws depend on what you're connecting and what materials and what size connector and what type of connector. There will be a different torque specification on it. So something that looks like it really should be a whole lot tighter may not be tighter. One great example, the bolts, the stainless steel bolts holding aluminum bars, conducting bars onto copper fittings in a power transformer. Okay, and that's pretty standard configuration. And if you over torque it, the first time that thing gets up to temperature, it will shear a 1/2-inch bolt like nobody's business, which is really spectacular. And then you can, if you got a big enough power supply, you can make a really efficient arc welder at several hundred volts.
So you're actually recommending that station engineers in their toolkit have a torque wrench, a measurable torque wrench.
It's not a bad idea. I carry two. I've got a 1/2-inch one for the big stuff, and then I've got the little socket nut driver type torque wrench for like MOSFETs and stuff like that. After a while, you kind of get a feel for it, but I still like to have the actual torque setting. Especially if I'm like the rectifier diodes in our older power transformer and rectifier transmitters. Those things are tightened to 200, 300 foot-pounds, 25 inch-pounds. So yeah, 300, I think that's right. But it's a lot of torque, and it's not quite what I used to work with this old guy. Bob might remember him. I just remember Floyd was his name, but he was a Harris factory trained guy down in Texas many years ago. And anyway, he used to say, you take it to the point of tink, but not quite. And I said, well, what's the point of tink? And he goes, that's that part where you go, and then all of a sudden it goes tink, and you go, whoops, shouldn't have done that.
That's a talent that needs to be trained in many cases, because I've been in many situations where I watched guys crank and torque something until they can't turn it anymore.
Mm-hmm.
But as you point out, the manuals or the quick start or whatever really should have said more, get yourself a torque meter and don't mess with this or you'll have trouble.
Well, and so for us, I mean, obviously we've got all the tools and toys because it's nature of the business, but we've got every single piece of hardware in our boxes has a torque specification. And everything is tightened to that torque specification. Now, after you shake it loose in a truck for 2,000 miles, all bets are off on whether that's where it ends up. So we try as much as we can with Loctite and stuff and lock washers to not let it work loose, but occasionally stuff like that will happen. And if you get something critical, like especially in a power supply or an RF cabinet, you absolutely should go back to the manufacturer and say, hey, what's the torque specification for the bolt that, and I'll give you another example. In an RF filter on an AM transmitter, those big ceramic capacitors that we use have brass hardware. You can turn brass hardware into brass cylinders really fast if you get a little too strong with the 1/2-inch wrench. So definitely find out what the torque spec is for stuff like that. Because if you strip it, it heats up even faster, and then the fire definitely will happen.
David Stewart's got a thing here about dealing with rotary phase converters and the effect. Although it looks like there's a pole transformer involved as well. Dave, want to tell us a bit?
Yeah, it's just like the note says. A guy was rebuilding a Continental transmitter, little one. This was the 3-cabinet, 11-kilowatt version, and he kept burning up screen transformers. We replaced the first one. Fortunately, we had thermal cutouts and other sensors and things, so we weren't burning down the building. But we went through 2 or 3 of the screen transformers, tried putting just barely big enough circuit breakers in front of it so that, okay, if it's drawing a lot of current, it would trip, and it would trip the breaker regularly. And then one night we burned up another of these. I started counting amps one day just counting amps, and I look at the pole peg and notice that the kVA rating of it was about half what the transmitter seemed to be using. And this was a co-op, and a very friendly co-op. We mentioned it to them. They brought us a much bigger deal, and it didn't burn one of these for a long time. But I was told by the company that made the phase converter that you can clip your AC power coming in. If you run it too large a current through too small a transformer, you'll clip the top of it. It'll start becoming square on the tops. And evidently a DC component comes out of the phase converter after that. And that run through just about any piece of iron, it'll have ohms of impedance. It may have a fraction of an ohm of resistance, and it will start drawing current.
Interesting. Interesting. Got another one to show in the grounding department for those of you that are enjoying that aspect.
That's about as good as I've ever seen, Barry.
Yeah.
Well, I bought it at a hardware store, so it's good.
I did see one once where the lug was held onto the ground bar by a bent 10-penny nail, but at least it was conductive. Your tie wraps don't even qualify there. And it's funny talking about the phase converters and the AC, and one of the things, and I'm trying to think on the fly because of course it was right at the top of my head when you were talking about it, and now it's totally gone. Getting of all the things I've lost, I missed my mind the most. But I remember now. I'm sure other people have seen this too, but have you ever been to a site where there's a circuit breaker and got the little piece of wire holding the circuit breaker back and bolted down so it can't trip? Now, I mean, of course, you still get the thermal switch inside, but yeah, I mean, I've run into several of them where I've seen 3-phase breakers that were braced up with a piece of pipe. And just don't do stuff like that. Avoid stuff. If there's a breaker tripping, usually there's a reason for it.
Am I back on again?
Yes, sir.
Okay, one of the best I've ever run into years and years ago, a fella called me. He was off the air, his FM was down, so I went up there to help him. And to make a long story short, we walked in the building, there was a puddle on the floor, and we opened the back door of the FM transmitter, which was off, so I grabbed the chicken stick and I go across the 3-phase fuses, and the last one I hit, there was a big arc of bang, and the AM transmitter shut down.
Nice. Tick, tick, bang. Yep. I mean, I've seen a lot of 3-phase breakers with 1-phase welded shut. So that's always entertaining.
Were you still dry after that, Bob?
That's a case of first you say it, then you do it.
That explains the puddle.
Yeah.
Yeah, actually, I was okay. I think the engineer kind of got scared.
Allow me to contribute an item to your electrical wonderment here. This was a 30 kilowatt BE transmitter, and it was sitting on a high school campus. It was owned by a school district previously, and they decided to put new AC power in. Well, okay, this is fine. And I went looking at how it was fed. Well, you entered this little shack at the base of a pole. And in this shack was a breaker panel. And it had two, are you ready for this now? Two 200 amp circuit breakers in parallel. Well, it had a 400 amp service. They didn't have any 400 amp breakers, so they put in two. Now, this gives you a lot of good feeling. Was the breaker turned off? Yep. Thankfully, it's all gone. Hi, Jeff.
Hey, Clay, how you doing? Then the question becomes, is the right breaker turned off? And we've had...
Well, they were left and right, so it was stereo.
Perfect. Well, that makes it all better. Now, the question is, were they a balanced pair?
I'm happy to say that it is all gone, and I wasn't responsible for its creation. But this is the thing, when you go into a site and you are not familiar with every aspect of the AC circuitry, you always want to suspect that some Nimrod, it's a technical term, was involved in it prior to that. I'm very happy to say I've got a couple major transmitter sites here in the Seattle area, and the guy that designed the electrical system has been very satisfied with his work. Yes, I am.
Yeah, The one thing I've learned over the years is that just like every mic is hot, so is every breaker. Even if I physically shut it off until I get the meter on all three phases, that breaker's still live. And it's managed to get me through 30 odd years with all the appendages that I started with, and no extras that I'm aware of, I don't think. So yeah, that's definitely a really good point to bring up. I ran into so we've had 2 injury accidents in 31 years at Nautel, which is, considering the stuff we work with, not too bad, I guess. 2 electrical injury accidents. Sorry, we had one mechanical. Apparently, a 6-ton press brake can do wonders if you get your thumb stuck in it. That's a whole different story. Anyway, so one of our electrical injury accidents was a guy was working on site and he was installing a surge protector. I forget exactly why, but for whatever reason, he needed to install a piece of braid, like 1-inch copper braid, you know, the woven copper braid. Picture solder wick, but 1 inch wide. And anyway, so he asked him, oh yeah, the breaker's off, you're good to go. And didn't measure it. And he ended up dropping this piece of copper braid across 2 phases of 600 volts. Well, drop solder wick across an AC connection, and you know what's going to happen. It turns into molten copper in a heartbeat. So he ended up with a good case of 2nd and 3rd degree burns up his hands and arms. Fortunately, everything made it through, and he was still able to come back to work after a while. But yeah, who was it? One of your presidents said trust but verify or something like that?
Yep.
Oh, that's lovely.
Oh,
That's
nice.
very nice.
Nice. Conservation of material. Yeah.
That's it. It drains the static from the PVC.
Something like that.
So I have a picture in my grounding presentation of it's a 1 kilowatt AM that's connected with a piece of just regular old 14 gauge wire to a cold water pipe. And because some engineer, the owner is the engineer, is the chief cook and bottle washer, et cetera, and so on. And an engineering friend of his told him that a cold water pipe was a good ground. The engineering friend probably should have specified that PVC cold water pipes are not the best grounds.
The operative word there is PVC, I believe.
Yeah, yeah.
Or PEX.
Yes. I remember one installation though where they were changing out the power transformer. It was already down from the pole. There was nothing feeding the building, but the electrician was still smart enough to go around with the meter and make sure that there was nothing sneaking in from God only knows where.
Yep. Larry, that looks like a almost like a forest fire picture. Is that a site fire? No, the trees are intact.
Well, this was a
shipping
Santa
container.
Rosa fire in October of 2017.
Mm.
And this was a translator site that we had in Santa Rosa. And you can sort of make out the coax tray that used to run across the top of the building, which
Oh.
fell into the building.
I see
This
a
was a
rack
cargo
door.
container that they'd moved up to the site, but it had a nice wooden deck all the way around it.
Oh boy.
And when the brush fire went through, obviously anything around it burned.
Mm-hmm. Yeah, and I know I worked with Tom Morris on some of the sites there. Some of the pictures he had from the fires down there. It was a year, 2 years ago, I guess, 2019 now.
Yeah, and I'll tell you a grounding story as well. I got called into a station at the Bay Bridge Toll Plaza about 6 o'clock in the evening. They'd gone off the air. And I went out there and the lights in the building were going bright and dim and bright and dim,
Uh-oh.
along with the tower lights. The transmitter was operating because it had 3-phase power, but there was no neutral in the building. And so with the tower lights, when they came on, they unbalanced everything. And that wiped out all of the audio equipment in the equipment rack. And the problem turned out to be a plumber had been out there earlier and had removed the sump pumps they used to pump the water out from the high tides. And the neutral had been disconnected in the building for years, and it was getting its neutral through the sump pumps that had been removed.
Whoops. We had a situation here at the house. We're surrounded by forest, and after a particularly big windstorm, I got up one morning and went into the kitchen and turned the lights on, and they seemed a little brighter than usual. And I didn't think much of it, and except I noticed that some of the appliances were on and some of them were not on, and that seemed weird. So being inquisitive, I grabbed a little pocket voltmeter that Barry gave out at the luncheon in the Riviera one year, many years ago, and discovered that half of my outlets were at 160 volts and half of them were at 80 volts. And that's what had happened. One of the trees had rubbed through the neutral lead coming into the building, so it just arbitrarily established its own neutral point based on the load on the lines.
Oh, yeah. The floating neutral. Yeah.
Yep. The more I tell these stories, the more I realize that it's just been a miracle that I haven't managed to burn this place down over the last 20 years.
Amen, brother.
I have an interesting story y'all might enjoy. My oldest client has a full Class C, and they had awful coverage. This was 35 years ago. So they flew me in to try to figure out what was wrong. And the first thing I did was hook up a scope to measure the incidental AM on their FM radio station, and they had 10% AM modulation at 120 hertz. Well, had to be a power supply problem somewhere, so I shut them down in the middle of the afternoon on a Friday, opened the back door, and I found that the three-phase power supply primary transformer for the driver's stage had been built with a phenolic bar across the top where the primary voltage attached to bolts that went up through this phenolic bar. But whoever manufactured the transformer, it wasn't the transmitter manufacturer, they just buy the iron from somebody else, hadn't put a lock nut above the phenolic bar underneath the attachment point. They were just tightening the nut down on the top so that the ring lug was on the bottom on a flat washer and then right on the phenolic, depending on the thickness of the phenolic to never change. This transmitter had been there for, I think 6 or 7 years at that point, and one of the connections had turned completely black. Wow. The phenolic was totally burned away. I'm surprised the transmitter didn't burn. We went down the hill to a hardware store and bought a whole bunch of hardware. And an hour and a half later, their coverage problem was gone because I had, extra nuts everywhere so that everything could, be hard pressed together like it should be. I don't know who builds these transformers, and apparently when they come into transmitter manufacturers, they don't always get inspected by somebody who knows the kind of thing to look for. But I thought that was a very interesting thing to find that early in my career, and that client is still with me 35 years later.
Wow. Nice.
How long did it take you to find the problem?
I got off the plane at 2 o'clock in the afternoon and I found it at 4:30. But see, at that time, the very first thing I would check on an FM radio station with coverage problems is incidental AM to see whether there was a serious tuning problem in a driver stage or a final stage or in an antenna, or whether there was some kind of power supply ripple frequency amplitude modulating the FM carrier. It's a really bad problem for a lot of radio stations, especially before the new solid state days, because, everything was analog.
So Grady, you remember the WALE 50 kilowatt? You and I went around on that once or twice over the years. You remember how if you shut down blocks C2 and B2, you get that nice 400 hertz hum?
Oh, yeah.
Well, I had a site with one of those co-located with a AEL FM, and if you shut those two blocks down, the 400 hertz going out on the AC line would kill the AEL's range. Same reason.
Wow. There you go.
Well, my story isn't in the power supply, but I found not one but 3 transmitters in this area that were so detuned that and the coverage was weird. I took the meter from 100%, took to 50, started looking for the dip, brought it back up to 100, put it back to 50, brought it to 100, put it to 50, 100. Fourth time I got up to 85, and the station was suddenly blasting around. The second one, the guy who was doing their frequency measuring every month, local TV engineer, he commented to me that he actually could hear this station from 70 miles away now, to which I sort of questioned, what was he measuring before? Now we're up to an hour here, and a few people are going to start fading away. So I'm going to do 2 things here. We're not going to chase Jeff away, of course, until he has to go. But I would like to mention that on the website, if you've got your newsletter, there's a very interesting little thing that our friend Dane Erickson put together. Another thing from Richard Rudman. And we even have a little thing on the site that you can, if you want to go find it. It's the famous story of the Rockwell retro encabulator, and all April 1 grin type stories and things to see. The other thing I'll just mention is that if there's something that you have that you'd like to share in terms of pictures, please remember that we're here and we're looking for sharing good stuff.
You know, Barry, talking about Dane Erickson's masterpiece, and I do have to admit that of all the people I mentored, he was one of the sharpest. But a couple of weeks ago, I had to sign my annual disclosure, so to speak, for my healthcare. And the wording in that took about 3/4 of a page of going round and round and round and round. And all I did was sign, I agree with any facts presented above. Signed, Philip M. Kane.
Ben Dawson kindly gave us a little experience when he was 16. Ben, if you got a microphone, you're welcome to turn it on and talk to us. Maybe
No
not.
Ben. No Ben.
No, says he was. He diagnosed a problem on the neutral, on the utility neutral, when he was 16, and the radio station didn't believe him at first. Which is a common problem where these guys that think they know everything, they don't understand that when somebody comes in and focuses in on what's going on. George, you had a picture there that I started to talk over, so if you'd bring it back.
Okay. Hi, guys. Yeah, I just wanted to share how quick he is. I was trying to figure out how to get it up on the screen. There it is. That's the WXFT channel 66 transmitter on the 101st floor of the Sears Tower in, I think, 2003. Had a voltage multiplier power supply in there, all solid state. One cap shorted, led to another, led to another, led to another. Yeah, wasn't much fun, but talking about things burning down the house, those darn power supplies.
Thank you. I could play the burning down the house song.
I got to roll because I've got another thing that I sort of skipped out in the middle of it to come hang with y'all because y'all are a lot more fun than that was. But at some point, somebody's going to expect me to show up again.
Well, Jeff, we're so glad that you spent some time with us today. And as always, the invitation is always out for your presence and wisdom and experience, both in the shop and in the field.
Yeah, and I'm so shy and I don't talk much either. It's always fun to be here. So I'll let y'all go and we'll talk to you soon.
Thanks, Jeff.